Okay, time to talk about parallel and perpendicular lines. And we want to remind ourselves that parallel lines are lines that are in the same plane but do not intersect. All right? So that's parallel lines. What do you think about perpendicular lines then? Perpendicular lines are going to be just the opposite. They are going to directly intersect. Parallel lines, however, are going to be lines that are in the same plane like this, okay? But they do not ever intersect. They never meet. Two non-vertical lines are parallel if they have the same slope and are not the same line. Does that make sense, you guys? Okay, so it's kind of like what I was just showing you here. Same slope, exactly the same slope, the same rate of change, but they're not the same line, because that would just make them the same line, not perpendicular, but identical. But if they have the same slope, and they're just separated by the same number of units, that means they're in the same plane, they don't intersect, but they're obviously going to have the same slope, but they're not the same line, then they are considered parallel. Okay? Any two vertical lines are parallel. Let's see if we can figure out, looking at equations, whether or not we can determine if lines are parallel. So you're going to go ahead and open your book to page 424 so that you can see the example. Okay, so Mrs. Fairbank gave us that direction. Look at the example on page 424, and what you're going to see there is something similar to what I just did with those colored pencils. You can see two lines on your coordinate plane that are not the same line. They do not intersect, but they have identical slopes. And we see that there in our example, because in that example on page 424, the two equations we are given are y equals 2x plus 7 and y equals 2x minus 1. And what they want you to observe about that is that in each equation, we have 2 as the slope. See that? Y equals 2x plus 7 or 2x minus 1. The only thing that's different about those two lines is not the slope, but where it intersects the y-axis. So, if we have these two equations, which are a little bit trickier, because they're not, each of the equations is not in our slope-intercept form, okay, then in order to determine whether or not they're parallel, we need to know if they have the same slope. That's the key to determining parallel lines. This equation here is easy enough to see. It's in the form y equals mx plus b. M is the slope. So if m, the slope, is the same between these two equations, then the lines will be parallel. In this equation, m equals -2/5. What does m equal in this equation? In order to determine that, we need to rewrite the equation. Okay, so I'm going to do that over here. So 2x minus 5y equals 10. I need to get this equation in this form, which means I need to get y by itself. First thing I'm going to do is I'm going to move these x's. So I'm going to subtract the 2x from this side, and I'm going to subtract it from this side, and end up with -5y equals, now because I want my mx first, I'm going to write this term first, so -2x, and this is a positive 10. Okay? All right, I'm almost there. I need to get y by itself. Be careful to divide not just by 5, but by -5, okay? Because we need it to be a positive y. And don't forget that I need to divide both of these by -5, every single term by -5, and I end up with y equals 2/5. This is positive. -2 divided by -5 is 2/5. X, 10 divided by -5 is -2. All I'm looking for is the slope. In this equation, the slope is 2/5. In this equation, the slope was -2/5. Are those equal to each other? Is 2/5 the same as -2/5? The answer, obviously, if I were to write it this way, is no. So these are not parallel lines, okay? These are not parallel lines. The answer here, are the slopes the same? No. Therefore, the lines are not parallel. It helps me remember when I'm spelling parallel that these two L's are next to each other and they look like parallel lines. Okay? All right, let's do the same thing here for our second example. Are these two slopes the same? This one is in y equals mx plus b form. So for this equation, we can see clearly that m, that is the slope, is equal to 2/3. If this represents a parallel line, then m will also be 2/3 when I write it in the form y equals mx plus b. So let's convert this equation to this form. I'm trying to get y by itself. Okay, first thing I'm going to do is I need to move this 3/2 x over to the other side, right? So y is going to equal, subtract it from this side, and subtract it from this side, and I get y equals negative 3/2 x, this is a positive 1, plus 1. So in this case, I've got 2/3, and for this equation, the slope, m, is negative 3/2. Are they parallel? Well, does 2/3 equal negative 3/2? No. So they are not parallel. Okay, the lines are not parallel. So if I was writing this as an answer on a test, I would want to write that in the form of a sentence. No, the lines are not parallel. Now what's kind of cool is that we can, now that we know that two parallel lines have the same slope and a different y-intercept, we can now learn how to write equations for parallel lines. Okay, let me show you how. So we're going to write an equation in slope-intercept form for the line that passes through 2, -4 and is parallel to the line with the equation y equals negative 3x plus 1. Okay. In order to figure out how to write an equation for this parallel line, I know that my new equation, the equation of the line that's going to be parallel to this line, has to share the same slope. So in my new equation, m has to equal -3. They must have the same slope, okay? But it's going to have a different y-intercept. So we know that the new line is going to pass through 2, -4. This line doesn't pass through 2, -4. So I've got to figure out how to write an equation with the information I've been given. Take a look at what I have. I have a point and I have a slope. That means I'm going to use my point-slope formula, y minus y1 equals m times x minus x1, to determine the equation of the line. Okay? Guys, we've been having a little bit of trouble with this and knowing which variable we put in which position. So let's just be reminded of it right now. Leave y and x alone. x1 and y1 are these 2 points right here. Okay? So here's x1, here's y1. Now we just plug and play. So leave y alone. We don't know what that is yet. We're just trying to write an equation. Y minus y1 is -4. So y minus -4 is going to give me +4. Because minus 4 is +4. Equals m, I know what m is, it has to be parallel, so it's got to be the exact same slope, -3 times, I don't know what this x is, here's my x1, x minus 2. Okay? Now I'm going to go ahead, it asked me for the equation in slope-intercept form, not in point-slope form. I needed point-slope form to write this to even be able to begin, but my answer ultimately needs to be in the form y equals mx plus b. Okay, so I've got to rearrange all of these terms now to put them in this form. So let's do that. I need to do this distribution first, so I'm going to end up with y plus 4 equals, distribute here first, -3x, -3 times -2 is +6. Okay, now I'm going to move some stuff around in order to get this y by itself. I'm almost there. I just need to subtract 4 from both sides. So I end up with y equals -3x. And if I subtract 4 from here, and I subtract 4 from here, I get a +2, right? +6 minus 4 is plus 2. This equation represents a line that's going to be parallel to this equation. They're not the same line. They have the same slope, but they pass through a different y-intercept. See that? And this line is going to go through this coordinate point, 2, -4. Pretty cool. Let's try example letter B. All right, so write an equation in slope-intercept form. So that means that's ultimately the form that I want my equation to end up in. But that's not the information I have. The information I have is simply that it passes through this single point. So I've got that point, and I know it's going to be parallel to this line here. If it's parallel to this line, they have to share the same slope. So the information I have for this equation and for my new equation is that they both have to have a slope of 4/7. I'm not ready to write an equation in slope-intercept form yet because I don't have enough information for that. The information that I have will allow me to put these numbers into point slope form. Remember that? Y minus y1, because I've got a y1 and an x1. This is y1. This is x1. That's what I've got. And I've got a slope equals, here's my equation. Let's just remember it. And let's plug and play. Okay, so y minus, here's y1 minus 2 equals, slope is 4/7. X minus, x1 is -3. So x minus -3, which is x plus 3. That's what that becomes. We're going to do the distribution. Y minus 2 equals 4/7 x plus 4/7 times 3 is 12/7. Okay, remember how to multiply fractions that way. All right, now I'm almost there. I need to add 2 to both sides in order to get y by itself, right? So I've got y equals 4/7 x plus whatever 12/7 plus 2 is, because I need to add 2 over here to get away from this side, and I need to add 2 over here. We remember when we are adding fractions, so I've got 12/7 and I need to add 2, but I need to convert it to 7ths, right? So it's going to be added to 14/7 because that's equal to 2. And I get, when I add 12 plus 14, I get 26/7. That's an okay answer for me. If it bugs you to have something that looks like 26/7 there and you want to write it as a mixed fraction, as a mixed number there, so you get y equals 4/7 x plus, let's see, what's that going to be? 3, 21, and 5/7. That's fine too, okay? Either one are just fine. All right, now that we have explored parallel lines, let's talk about perpendicular lines. This is fun, guys, okay? So, this should not be the word toe, this should be the word to. If you want to fix it, go ahead. Any two lines are perpendicular if their slopes are negative reciprocals of each other. A vertical and a horizontal line are also perpendicular. That makes sense, right? So if I've got a vertical line and a horizontal line, then those two lines are going to be perpendicular, okay? Now, once we start messing with these lines, we're going to see how their slopes, in this case, we wouldn't be able to, we're not going to analyze something that looks like this because the slope of this line right here is undefined. We know that. Okay, I just want to show you that so that you understand what they're talking about with a vertical and a horizontal line. Now, lines can be vertical and horizontal this way too, right? I mean, once I flip them and just shift them around a bit, and I can see that those lines would be perpendicular as well. So the thing that we want to focus on right now is the slope of perpendicular lines. Remember that the slopes of parallel lines are the same, and so it makes sense if we use our reasoning abilities that the slopes of perpendicular lines are going to be the negative reciprocal. The negative reciprocal, okay? Remember, if I've got a positive slope going this way, if the line's going to be perpendicular this way, then it's got to have a negative slope. So a positive slope, a negative slope, and they're going to be, and we explored this a little bit in our transformations, right? They're going to be reciprocals of each other, all right? So Slopes of perpendicular lines are negative reciprocals. So let's explore that a little bit as we finish up our lesson here with this information and figure out if we can write some equations here to help us see whether or not the information we have gives us what we need to determine if these slopes are negative reciprocals. Okay? Okay, here we go. Line 1. We're going to determine between line 1 and line 2 if these slopes are negative reciprocals. So we need to remember one more formula. Okay? Remember, slope is equal to y2 minus y1 over x2 minus x1. If I've got 2 points, then I've got a y1 and a y2 and an x1 and an x2, and all I've got to do is put them in the right place and I can determine the slope. So I'm going to call this x1, I'm going to call this y1, I'm going to call this x2, and this y2. And I'm going to get a new pencil because my pencil's getting a bit dull. Let's determine the slope. Slope is equal to, in fact, I think I'm going to put something underneath here again so I have a bit smoother writing surface. Okay, slope is equal to y2, which is 1, minus y1, which is 5, over x2 minus x1. And I get negative 4 over negative 1, which is equal to 4. Okay? If line 2 is going to be perpendicular to this line, it needs to have a slope that is the negative reciprocal. The reciprocal of 4 is 1/4. Remember that, guys? So that means that line 2 must have a slope of negative 1/4. That's the question. Does it? Okay, because that's the negative reciprocal of 4. Would be negative 1/4. So let's check it out. y2 minus y1 over x2 minus x1. And I get negative 1 over, is that right? Nope, I did that wrong. I hope you caught that. 3 minus 2 is simply 1. I think I wanted them to be perpendicular so bad. But look at this. They're not. They were so close, but they didn't quite make it. This needed to be negative 1/4, and it's not. It's positive 1/4. So our answer to this would be not perpendicular lines. Okay? Line 1 and line 2 in this equation are not perpendicular. Let's see what we've got here with our example here in letter B. You don't have a lot of space to write here, okay? So do your best. In fact, I think that I'll do line 1 over here just because I need the space. y2 is 4. y1 is 2 over 2 minus negative 2, which is plus 2. Okay, so I get m equals 2 over 4, which is equal to 1/2. Okay, that's the slope of the first line, is 1/2. If the slope of this line is the negative reciprocal, so the reciprocal of 1/2 is 2, right? 2 over 1, and it's got to be negative. So if m equals negative 2, if it does, then we've got perpendicular lines. Let's give it a try. Okay, so m equals y2 minus y1 over x2 minus x1, and I get 3 minus 6 is negative 3 over 5 minus 3, which is 2. Are they perpendicular? I needed it to be negative 2. It's negative 3/2. So again, the answer is a disappointing, at least for me. I just wanted one of them to be perpendicular, but didn't work out. So the answer to this one here is the same, not perpendicular lines. Okay, for this guy here and that one there, not perpendicular lines. All right, that's how we determined whether or not those lines, based on just simply having 2 points, were perpendicular. We compared the slopes to each other. Let's talk about now how to write equations of perpendicular lines. Okay, so we've got to remember all of these formulas that we hopefully are storing away in our brains now, and we're going to use them here to write equations of perpendicular lines. So here we go. Write an equation in slope-intercept form. It's not probably how I'm going to start, but that's how I have to end. For the line that passes through the point 1, 2 and is perpendicular to a line with the equation y equals 1/6 x minus 3. Okay, looks like I'm going to need to start with point slope form again because that's the information I have. I have a point and I've got a slope. For this line here, which is in the form y equals mx plus b, here's the slope. Okay, the slope is 1/6 in this line. The slope of my new line, if it's going to be perpendicular, needs to be the negative reciprocal. So my new line needs to have a slope of, the reciprocal of 1/6 is 6/1, okay, just 6, and it needs to be the opposite, so negative. This is what I need to have for the slope of my new line. Now I know, because I've got this point here, okay, so remember my point slope formula is y minus y1 equals m times x minus x1. This is x1, this is y1, and here's m for my new line. I'm going to put that information in. Y, I don't know what that y is yet, but I know what y1 is. There it is, minus 2 equals negative 6 times x, oh, not that x, I don't know what this x is yet, x minus 1. Do the distribution, y minus 2 equals negative 6 times x is negative 6x, negative 6 times negative 1 is plus 6. I'm going to add 2 to each side, and I will end up with y equals negative 6x plus 8. That's the equation of a line that is perpendicular to this one. The slopes are negative reciprocals, and I know by using the information that I got, okay, that this line is going to pass through that point. Let's try it here for our example letter B. Write an equation, again, in slope-intercept form. That's where I'm going to end, not where I'm going to start, because the information I'm given is a point, and I know that it needs to be perpendicular. If it was parallel, we wanted to have the same slope, but nope, perpendicular. So that slope needs to be the negative reciprocal. The slope of this line is 4/7. The slope of my new line, the one that I'm trying to write, needs to be the negative reciprocal. So the reciprocal of 4/7 is 7/4, and it needs to be negative. Okay, so I've got that. Again, I start here because this is the information I have. I have a point and I got a slope. So I'm going to use point slope form. That makes sense, right? Y minus y1, which is 3, equals this new slope, the negative reciprocal, negative 7/4, times x minus x1, which is negative 1. X minus negative 1 is x plus 1. Those two negative signs come together to make a positive. I will now distribute negative 7/4, negative 7/4 x. Negative 7/4 times 1 is negative 7/4. I will add 3 to both sides. I'm going to add it to the like terms, and I end up with y equals negative 7/4 x plus, this is going to end up being 5/4 or 1 1/4, right? But let's just do it for good measure. So I've got negative 7/4, and I'm trying to add 3. Remember that? But I need, in order to add fractions, they need to have the same denominator. So I need to convert 3 to having a denominator of 4, which means it's going to be 12/4. That's equal to 3, right? And so when I add these together, I'm going to get negative 7/4 plus 12/4 is equal to 5/4. So that's my y-intercept. This is just fine with me. Again, if you want to write it as y equals negative 7/4 x plus 1 1/4, because you don't like improper fractions, that's fine. If you want to write it as a mixed number, write it as 1 1/4. Either answer is perfectly acceptable. Almost done, guys. Let's do a little bit of application now, looking at line segments in a triangle. Okay, so the reason that we're calling this geometry instead of algebra right here is because we have a shape. Now we're going to use the slopes of these lines. Let's go ahead and label these points. This is A, this is B, and this is C. And we need to make sure that our graph is labeled as well. All right, so I recognize that this is slightly off. Let's try to forgive that. Here, I'll make it a little bit bigger. Just pretend like this whole thing is the the line. Okay, we're gonna call this right here, we're gonna call that 0. All right, let's call that 0. 2, this is gonna be 4. 6, let's make this 8 up there. Okay, so here's 0, this will be negative 2, this will be negative 4 here. 6, this will be negative 8. Let's make, again, I'm making this point right here. This is my 0, 0. All right, so 2, this is going to be 4. 6, this will be 8 here, and then this will be negative 4 right there, and negative 8. All right, sorry that's a little bit off there, guys, but let's do the best we can, and I will go ahead and give you the coordinates of these points since they're a little wonky the way they're laid out on this coordinate plane. Okay, so B right here is going to be 3, 1. Those are the points. A is going to be negative 6, 8. And C is going to be negative 4, negative 8. So I recognize that those are not exactly hitting those points, but that's because our axes got a little bit off of our coordinate plane. All right, so we're going to use these points here, and now we're going to actually look at our problem. Use the slopes of the line segments to show that ABC is a right triangle. Okay, what we need to know about right triangles is that the place where we have a right angle in our right triangle, which is right here, we know, based on what we know about right triangles, that segment AB is perpendicular to segment BC. Okay? Segment AB is perpendicular to segment BC. If these lines continued, we would see that they're exactly perpendicular to each other because they make right angles. So that's how we understand that. So just by what we've learned so far, we understand that the slope, okay, of AB here to here, in order for these to be perpendicular lines, their slopes needs to be the negative reciprocal of the slope of line segment BC. So to determine, to show, okay, that this is a right triangle, this slope, the slope of this line, should be the negative reciprocal of the slope of this line. So I'm going to go ahead and use my points now to figure out the slopes of AB and BC. And if they are negative reciprocals, then I've got perpendicular lines. Okay? Okay, so I've got 2 points for each one of these, which means I can go ahead and throw them into my formula. Remember that formula over here, guys? M equals y2 minus y1 over x2 minus x1. So AB is right there. Here is x1, y1, x2, y2. All right, so y2 is 1 minus y1 is 8 over x1 is 3 minus negative 6, so that's plus 6. 1 minus 8 is negative 7. 3 plus 6 is 9. If BC is 9/7, if it's the reciprocal of this and it's the opposite sign, then I've got perpendicular lines. So let's go ahead and see if it's 9/7. I'm going to use my same formula here. And now I've got new points. I've got 3, 1 and negative 4, negative 8. Okay? So it doesn't really matter